Hi guys, welcome back to my mathematics tutorial. Once more, my name is Peter C. Duckworth Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with finding derivatives of trigonometric inverse function using trigonometric substitution method. So this is question number 32, and in previous lesson, we saw a few problems under this method, so you can just review those problems. And also, one basic thing that you actually need to be able to, easily deal with this method is understanding the trigonometric identities. So at least those basic identities like the half angles, the double angles, the sine of a sum, cosine of a sum, difference identities. So at least you have to understand those basic identities. Then you can easily substitute because you have to know what you need to substitute so that you arrive at something that gives you your desired result. Now, our objective here is to ensure that what is within this angle turns into cosine so that cos inverse of cos of an angle equals to that angle. It makes it simple for us to do. So let's now solve the problem. So now what we can do here is that we can rewrite this expression as cos inverse of 2 over the root of 13x minus 3 over the root of 13, the root of 1 minus x squared. What do you see? We have this term minus this term. But within this term, you have this times this. You have this times this as well. So if you can just remember, cosine of a sum is equals to cosine of x minus cosine of a sum. Cosine of x plus y, right, is equals cosine of x cosine. Now let's bring it in minus fit. So it's cosine of x plus y equals cosine of x cosine of y minus cosine of sine now of x and sine of y. So this is cosine of a sum identity, right? So this term here represents the first term, and this term represents the second term, and there's a minus between them. We want to substitute. So it means that our cos of x, it means that cos of x is equal to 2 the root of 13. Right? Now, from the red triangle, so this is x, for instance, x degree. Cosine is defined as adjacent side all over hypotenuse. So the adjacent side is 2, and the hypotenuse is the root of 13. So we can now find this, which is b. So we know that c squared equals to a squared plus b squared. What is c? C is the hypotenuse, so it's the square root of 13 all squared, which is just 13. A squared, we can consider this 2 to be a, so it's 2 squared plus b squared. So 2 squared is 4. We send it across, it becomes minus 4 equals to b squared. So 13 minus 4 is 9. So it's like saying b squared is equal to 9. Take the square root on both sides. It means b is equal to 3. So this b9 is equal to 3. So that is, if cos of x is equal to 2 over the root of 13, it means that sine of x will also be 3 all over the root of 13. 3 over the root of 13. And that's exactly what we see here. This is the position of sine of x. Then this is the position of sine of y. But what is cos of y? So we know that cos of y is equal to x. This is x. So if cos of y is equal to x, then what is sine of y? Sine of y is equal to the root of 1 minus x squared. But this x squared is this x is cos of y. So it can be written as cos square y. So we know that the square root of 1 minus cos square y is just equal to sine of y. So with all of these now, we can replace in the problem. So therefore, we have y equals to cos inverse of. Now this is now 2 over the root of 13 is just cos of this cos of x, and this x now is cos of y minus this is now sine of x and sine of y. So this is an identity which leads us to cos of x plus y, cos inverse of that expression. So cos inverse of cos of x plus y is just equal to x plus y. But what is x plus y? That's what we need to know. What is x plus y? So we know that cos of x was 2 all over the root of 13. So we can solve for this x, thereby saying, let's take cos inverse on both sides. So cos inverse of 2 all over the root of 13. So this will now give us x is equal to cos inverse of 2 all over the root of 13. So this is the first one. But the next one, what is our y? What is this y? We don't know the y. So we also know that cos of y is equal to x. So if cos of y is equal to x, we can take cos inverse on both sides. So it means cos inverse of y of cos of y is just equal to y. So y is equal to cos inverse of x. So we can now use these two values. So we have y equals to x plus y. X now is cos inverse of 2 all over the root of 13 plus y is now cos inverse of x. So y now equals, what do we have? The derivative of this expression is minus 1 all over. Now, the square root of 1 minus x squared. Now, what is x? X is this expression, which is 2 all over the root of 13 times the derivative of the angle. Now, the angle here is just a constant. So the derivative of this constant goes to 0. So in fact, no need of us even applying this first method, because we know that this entire thing is a constant since we do not have x. So whenever you see it like this with no x or no variable within it, it's just a constant. So this whole thing is just a constant. So this is just equal to a constant, which is now 0 plus, what is the derivative of this expression? Derivative of this expression is minus 1 over the square root of 1 minus x squared. So 1 prime now is just equal to negative 1 over the root of 1 minus x squared. So this is how we find the derivative of this expression. So thanks all so much for watching, and see you in our next lesson. Thank you.